guys, this is our second day and I studied about convolutional neural networks, recurrent neural networks and attention mechanism, I guess. Yes, attention mechanism, because I will talk about these topics. Okay, so let's start with convolutional neural networks, and as you can guess, they're different than neural networks and they treat data as spatial, and instead of neurons being connected to every neuron in the previous stage, they are instead only connected to the neurons that close to them and all have the same weights. Okay, the word convolutional refers to filtering process that happens in this type of networks. And we will talk about the other layers as well, such as ReLU layer and fully connected layer, and also pooling layer. I hope, I will talk about that too. So the ReLU layer is rectified linear unit layer, by the way. That layer ensures nonlinearity as the data moves through each layer in the network. And we can also, it is like an activation function, so we can use other activation functions, I guess, other than ReLU. And fully connected layer allows us to perform classification on our data set, basically. So pooling layer basically downsamples or reduces the sample size of a particular feature map, and this makes processing faster because it reduces the number of parameters the network needs to process. And there can be many ways, but I know about two of them, so I will describe them to you guys. And max pooling takes the maximum input of a particular convolved feature, right? And average pooling is just taking the average of them. And I'm turning back to the convolutional layer. You can imagine that as a window, and we are sliding this window, and this is our filter actually, and it works by placing a filter over an array of image pixels if we're talking about images, and this then creates a convolved feature map. There are also things like striding, padding, but I didn't mention them on my notes, so I'm not going to mention about them right now. To perform classification again, we need to move in the fully connected layer. To do this, we need to flatten things out. And okay, so there are many ways to train CNNs, convolutional neural networks, and in unsupervised learning for unlabeled data, we can use autoencoders or also GANs. To mention autoencoders, they allow you to squeeze the data in a space with low dimension. I will mention about autoencoders like that. So you're going to encode your inputs, and you're going to do your CNN stuff, and then you're going to decode it. Basically, you're going to reconstruct your data again. It's basically like that. It works basically like that. And another way to study about unsupervised learning is basically GANs, which are generative adversarial networks. And you basically train two networks. I'm not very well at GANs. I know them about like a week, so I'm not very well about, I don't know very much about them. But you train two networks, and the first gives you artificial data, and that should resemble the data in the training set. And second is discriminative network, and it should distinguish okay, and so it's okay, so it should I can't tell the words, okay. So it should distinguish between the artificial and the true model, okay. And I know like that I'm not quite sure about it, but that network will be successful if the second model will understand which one is artificial and which one is the real data very well. I know like that. Don't blame me if I'm telling you something wrong, okay guys? Okay, let me mention about RNNs. We are using RNNs basically if our data is changing on time, changing with time, I'm sorry. It has a simple structure with a built-in feedback loop, allowing it to act as a forecasting engine. But in recurrent net, the output of a layer is added to the next input and fed back into the same layer, which is typically the one layer in the entire network. There is a problem about this network type actually, because if you're training this model like 100 times, it will actually train itself for like such as like 100 layer of neural network. In order to solve this problem, there are gating units basically, and they're such as LSTM and I couldn't read what I wrote right here, so there is LSTM and something like GRM. Differences between RNN and CNN are basically, whereas a convolutional neural network is a feed-forward network that filters spatial data, RNN feed data back into itself, and so RNNs are better suited to sequential data, as you can guess. And CNN is able to perceive patterns across space. RNN can see them over time. Okay. Well, let's talk about attention mechanism, and it's just basically like focusing and high resolution on certain parts of the input, while the rest of the input is blurred or low or in low resolution. If we are talking about images, we just don't look at the entire picture when we are using attention mechanism. We are just separating the images on parts, on regions, and we are just focusing on the sum of that regions, focusing on the particular regions. Okay, so there are two ways actually: soft attention, different parts and different subregions, and it's deterministic. And the other way is hard attention mechanism and only one subregion that we're focusing. And this is random, so it is stochastic. So it is stochastic, okay? So RNN can learn temporal and context features, especially long term, and dependency between two entities, while CNN is capable of catching more potential features. I guess that's all for today, guys. Actually, it is not all for today. I also studied about linear algebra and probability things, but I don't really want to talk about them right now because they're just literally boring things. So that's all for today. I hope you're like getting into my stuff,